Okay, we talked about binding receiver in the last video. Let's have a little bit of a chat about servos. Servos are electric motors, but unlike a normal electric motor that goes round and round and round to power a robot, servos only go one way, a slight distance, a certain distance, back to center and back the other way. Okay, this is called, its most basic form, PWM, or pulse width modulation. With a receiver, I have my output channels. Now, for this particular receiver, the top row of 3 pins was binding. Next row of 3 pins is throttle. Remember, the outside pins are negative, middle pins are positive, inner pins are data, where the signal gets sent down the data pipe. I've got throttle, aileron, elevator, and rudder. Now, TAER on this particular system, it will vary depending on your brand, what brand you have. Down here is gear, and I could have perhaps my undercarriage or my flaps on that channel. And each channel is outputting a PWM signal to the servo. So if I plug this into my aileron channel, just here, and another servo I would plug into, this is going into, I'll plug that into my elevator channel, it doesn't matter. I'll just take it out and put it in the aileron channel there. This one here might be my elevator, again negative to the outside, and that's going in my aircraft down to my elevator for pitch. And what would happen is you'd have throttle going to your motor. If it was an internal combustion motor, it would be a push rod coming out of there to your throttle linkage, which would open or close the throttle on your engine. If it's electric, like this, you'd have a speed controller, and I'll talk about that in another video. So back to servos. You see I've got them plugged into the channel. It's assumed that we've got servos plugged into all my channels. You send a signal, say a roll signal, center position for aileron, a pulse width of 1.5 milliseconds is being sent. If I roll all one way, the servo will, I haven't got this plugged in, the servo will go all one way, like that. And that would be, say, 1 millisecond, 1.0 milliseconds, 1 millisecond. And all the other way, back through center, back to the right-hand side is 2 milliseconds. The servo would go that way. So depending on the width of the pulse, if the width of the pulse is 1.5 milliseconds, the receiver interprets that, sends the signal to the servo. I'll say it once again. I roll a digital signal, a Spectrum proprietary digital signal is sent to the receiver, which sends, the receiver itself picks that up and says he or she has rolled hard left, and it sends a pulse width of either 1.5 milliseconds in the center, 1 millisecond all one way, it could be the other way, but all one way, or if it's back the other way, it's a pulse width of 2 milliseconds, 2.0 milliseconds. If I come back to center, so it comes back to center, that's 1.5 milliseconds. Same on all the other channels. Okay, center, I can undo that screw, because I don't know exactly where this arm's been placed. 1.5 milliseconds is center stick on any channel. This is elevator, I think I said, so right there, all one way, the servo would move all one as far as it can, which is 1 millisecond. Back the other way, servo would move all the other way. I'm setting a pulse width of 2 milliseconds from the receiver to the servo. You can imagine that if I was to graph this, it would be this kind of square tooth shape like this, with each width of the pulse 1.5 milliseconds if it's the center. There's a 20 millisecond gap, and if I go hard one way, whatever way that is, it'd be 1 millisecond, so the pulse width is shorter. at the width of my finger maybe. And if I go hard back the other way, a longer pulse width is sent, 2 milliseconds. And that's the essence of communications between a receiver and a servo, is pulse width modulation. Now there is another system called PPM and other variations of that, where instead of everything being on, instead of all your channels being separate, you just have one output. And the signals are sent one after the other. And the receiver can interpret that, and the servo can interpret that. It knows where it is. So your might be the fourth signal in line. So they're lined up in sequence rather than separately in parallel. But in essence, all you really need to know about is PWM on your separate channels, and 1.5 milliseconds, correction, 1 millisecond is one way, 1.5 milliseconds the servo knows to go to dead center, 2.0 milliseconds it goes the other way. It's Servos 101. There's different sizes too. There's little small, you get actually smaller servos than this. This is a 9 gram servo. I've actually seen like 1.5 gram servos, which are tiny. I've seen, this is an 18 gram digital servo, metal geared, 18 gram. And this is, I think it's about 40 grams, this bigger servo, and you can get bigger ones again. Servos can come in high torque, low speed, or higher speed, lower torque. You can imagine this is connecting to a control surface, and the air resistance on that control surface is pushing hard against the control surface, which in turn will be pushing hard against the servo. And so you'd want a lot of strength in it. On a servo that might be operating a tail rotor on a helicopter where you want really, really quick response, you need a lot of speed on those. Very, very quick response because of how fast the helicopter is moving in yaw and the correction that the tail needs to do. Servos are also interesting. You never want your servo to bind as that moves that way. You don't want it to catch on anything like a part of the fuselage of the aircraft, because it will continue to push if there's something holding it. And it will start drawing power through your receiver that it's connected to and start sucking power out of your battery. And if there's an autopilot in the system, it can cause your autopilot to reset in flight, which is really bad, your loss of aircraft. You can feel these things as they're energized, and if you were to push against it, it will push back against you. Okay, the harder you push, the more it'll push against you. Servos can be hacked in terms, you can actually buy them. Radio control yachties have winch servos which just go round and round like an electric motor. You can get online and have a look at how to hack a normal servo to make it into a winch servo or a pulley, so it just goes round and round and round. Of course, you wouldn't want to have that in your aircraft, but you might want to have it for some reason like lowering something perhaps. Servos. Remember, pulse width modulation on each channel. 1.5 milliseconds is your center, 1 millisecond one way, 2 milliseconds is the other way. And think of this square kind of tooth graph with a gap in the middle. So it's always pulsing. It's like you're pushing against something like that. It's always pulsing the servo, just doing it so quick you don't notice. The servo will hold the control in a position, whatever that position is.